So my name is Peter Gross. I'm Vice President, Mission Critical System for Bloom Energy. Bloom Energy is a company manufacturing solid oxide fuel cells, and my role is to take these devices, use them in data center and other critical facilities. If you look at the entire utility infrastructure, there are major concerns at every level. If you remember events like Katrina or Sandy or Fukushima or San Onofre in California, if you consider the risk of cybersecurity, cyber threats directly addressing the utility infrastructure, there is a whole slew of factors that are raising interest in distributed generation. More important, primarily, is the aging of the utility infrastructure. The national electric grid is widely considered the greatest engineering achievement of the 20th century. But it's an aging infrastructure. The cost associated with the distribution at every level. An interesting statistic is that between 1960 and 1989, there are 6 major utility failures. A utility failure or event is 1 million man-hours. 1 million people affected by power interruption for an hour is a typical. So between 1960 and 1989, there were 6 events. Between 1989 and 2016, there were 39 events. So it's a significant increase, and by no means I'm implying here that the grid is unreliable. But still, in today's environment where digital power is essential to the welfare of our society, mission critical environments, primarily data centers, are so dependent on power that there is more and more of this tendency for companies, enterprises, to try to get more of a control over their own power destinies. So that brings us to the concept of distributed generation. If you look at evolution of the computing from mainframe to distributed, if you look at the evolution of telecommunications from central offices to smartphones, the same trend is starting to take shape in terms of power distribution. And once again, I'm not implying here that the power plants will disappear. That's not what I'm saying. But I think that more and more, it's a direct effect of the whole renewable energy growth in the whole in our society. We see more and more of them. Now, when it comes to mission critical facilities, data centers in particular, there is no real renewable power source that could address the reliability, the sustainability, the energy efficiency, and also the cost. I mean, these are the factors that determine these are the main priorities for a data center. Intermittence is not compatible with a data center, obviously. Yeah. So solar and wind, maybe with storage, but storage is not there yet. The only, in my opinion, and I might be a little subjective here, in my opinion, the only viable solution that addresses all these things is a fuel cell solution, because it's clearly addressing all this objective. In other words, it is a major carbon reduction contribution. It is cost effective with respect to utility, eliminates the need for a lot of the infrastructure components that are essential part of the traditional legacy architecture for data centers, which ultimately results in higher reliability, is the only solution that relies on 2 independent sources of energy. One is the utility grid, and the other one is the gas supply, which are independent events and have this reliability contribution. And finally, there is a energy efficiency improvement. There are other distributed generation solutions. I'm not implying here that the fuel cell is the only one. You see, CHP solutions using either gas-driven turbines or gas-driven engines, and these are viable solutions, especially at the multi-megawatt, 50 megawatts or higher, where there is some cost efficiency. But the difference is that a fuel cell solution has an inherent advantage because it's designed to operate in conjunctions with the grid. The fact that the fuel cell delivers DC power, and then it has two sets of inverters, one directly connected to the load, the other one connected to the grid. So, and the dynamics, the arbitrage between the two sources of power is such that you always provide the highest priority to the critical load. The rest of the power goes to the grid. By doing that, you provide, you maximize the contribution of the source, because you always deliver full power and constant power, which is beneficial both to the source and to the supply and to the load. In terms of magnitude, fuel cells are a long way from addressing our energy needs. But like anything is the first step. The goal is ultimately to provide reliable, cost-effective, affordable, clean power to the world. Data center is a subset of all these possible applications. But if you look at the world where 2 billion people don't have electricity, and they're gonna do exactly what happened with the telecommunication business. They're gonna totally bypass the need to build big power plants and transmission and distribution to crisscross the country, and they're gonna go directly to these kind of sources. So these are the first steps, and there are clear applications for stationary fuel cells in this kind of applications. But in the long run, we're going to see these distributed generations taking hold all over the world, especially in places where there are no other options. When DCD decided to organize this event called Energy Smart, I was extremely enthused, excited about this, because it's the first time that anybody really focuses on the intersection of technology and energy. And if you look at the convergence of these two essential elements of today's society, is you realize the importance of this, and the fact that we are able to bring on the same podium utility executives, senior people on the utility side and senior people on the data center side, and having this dialogue, because one of the issues of this industry is that there is this gap, this disconnect between the two sides. Data centers essentially relied on their own infrastructure, and then utility was there, but never being a vital component of the critical infrastructure support system, simply because utilities were oblivious to the specific requirements of the data centers. This is a changing world. Things have evolved dramatically in the last number of years. Everybody recognized the fact that the digital economy is defined essentially by the overlapping intersection of these two components. And now, for the first time, we had the opportunity to sit down together and discuss these issues. And the key to this, to the success of Energy Smart, is to identify the key players on both sides, primarily on the utility side. I think that most data center executives are well aware of the issues related to power. And if you look at the hyperscale players, the whole issue of renewable, the whole issue of reliability and sustainability, and more importantly of economics, to a certain degree related to economic incentives, is very important. On the utility side, data centers are a very visible element of the whole infrastructure, but there are probably more important or larger customers in terms of overall needs than data centers, so that having a direct access to executives at the in the utility world that have they are willing interest in having this dialogue is what will make Energy Smart really effective and useful. One important aspect is the fact that historically data centers have buffered their impact of utilities. If you look at the data center architecture, where you have UPSs and batteries and standby generators and all kind of other adjacent components, made the utility element not that important. I mean, obviously it's critical, but not. You can always survive without it. If you look at the original tier system developed by IAPTime, essentially says that the data center has to rely on its own infrastructure before relying on utility. Utility is essentially an economic benefit, not a primary source of power, which is debatable. But the point is that now, with the transformation of the whole industry, primarily driven by cloud, by the reliability and the resiliency requirements are dramatically changing. OCP now relies on direct utility power, unmitigated, going directly from the utility entry point into the facility to the server. And there are many other architectures that will eliminate the need for all these other components. So now the importance of the utility, the quality of the power, the reliability of utility power is becoming a lot more critical. So that's why I believe that this discussion, this alignment of utility and data center is becoming a lot more important than it used to be. I've been involved with DCD for a long time. I think it's by far the best conference. It's because it's very focused on what's really important in today's world. This industry is changing so rapidly, especially in the last few years. The transformation has been so dramatic, and unless the professionals involved in this industry stay really very current to what's happening, the dynamics of this, and there is a long list of that. And having a forum where you have really high caliber speakers that are really focusing on the most pressing issues, it's very important. There are a lot of other conferences, but I think that no other conference has the ability to attract the kind of attract the quality and level of speakers. And you look at the attendance. There are so many high level executives in this industry that attend that. So I think that's